Objective number 2, local extreme values. The first derivative test. Suppose that c is a critical number of a continuous function f. If f prime changes from positive to negative at c, then f has a local maximum at c. So let's look at the graph below, the first one. So let's assume that we have C is right here, and you notice that the tangent line on the left side of C go positive direction, and the tangent line on the left side of C go negative direction. So when we go from smaller to bigger, from left to right, so the f prime from positive changing to negative. And we can see from the graph that at C, f has a local maximum. Part B, if f prime changes from negative to positive at C, then f has a local minimum at C. Look at the graph below, number 2 below. This is the C, assume we have that, and then we see that from the left side of C, the tangent line go negative direction, and the tangent line on the right side of C go positive direction. If we go from left to right, we see that f prime change from negative to positive, so we say that C is a location that f has a local minimum. Then part C is said that f prime is positive to the left and right of C, or negative to the left and right of C, then f has no local maximum or minimum at C. The third graph, we draw the tangent line. This is positive, positive, and C is right here. We have C at 0, right? So C is, we would think that C will have a local max or min, but that is not true, because you can see that we have a positive tangent all the way for the curve. So C is not local max or local min. Similarly, the last graph, the tangent, if we draw the tangent line along the curve, all of them are in negative direction. So we have a C, and C is not a local max or a local min. Example number 2, we want to find the local minimum and maximum values of the function f in example number 1. In order to get the local max or local min, we need to see the changing in the side of the f prime. Okay, so we go back to example number 1 and recall that we have -1, 0, and 2 are the 0 of the f prime, and we already checked the sign negative, positive in the interval. Now we draw the line like this so that we easy remember. So negative, so we go down, okay, and then positives go up. So like this, we have a minimum, local minimum. And we have from 0 to 2 is negative, so go down. So this is max. And 2 go to infinity, so we will have at 2 gonna be min, okay? So we will answer the question is f of -1, and we plug in the function f. You recall the function f in example number 1. F of x equal 3x to the 4th minus 4x cubed minus 12x squared plus 5. What all we need to do is plug in -1 into the function f, and we will get 0. And we say is a local mean. Then we have f of 0 is 5, and we say is a local max. And we have f of 2 is equal -7, and it is a local mean. Okay, so changing the sign from negative to positive. So let's go back and review from negative to positive, negative to positive. So we have a B, part B, local mean. And from positive to negative, so we have part A, which is local max. And so on, okay? We have, in this case, is part A and part B only.